Okay, guys, shall we start?
Mm.
So, are you guys clear about the post process? How NVRAM works, how EPROM works?
Sir, but yesterday recording is not sent
Yeah,
yesterday.
I will share after this class. No worry. Today's recording as well.
Okay, sir.
So, let me check. My screen is visible. Is it visible?
Yeah.
So, today's topic is we will discuss about the headers. Anyone who knows about headers? Anyone? No. So, this question is especially asked in TAC. If you will apply for the TAC profile, Technical Assistance Center, either for any company like Cisco, Sienna, Juniper, they will ask you. So, I have sent an image in group. Have you people saw that image? Please reply me, guys.
Yeah.
Anyone who can tell about the headers?
Yeah. Next one will be like sequence number.
How many bits in sequence number? 32 bits.
4 bytes.
4 bytes are 32 bits.
Yeah.
Next one will be the
Acknowledgement number.
and next one will be we will have to perform header length, Ravi Shankar, are you there?
Yes, sir.
Reserve, flags, and window size. So this one will be 4 bits. This one also will be 4 bits. This one will be 8 bits. And this one will be 16 bits. Next one will be Subhijit.
Yes, sir.
Header checksum, and it will be 2 bytes. So are you guys clear about bits and bytes?
Sir, header checksum is 16 or 2 bytes.
16 bits means 2 bytes. Urgent pointer. Okay. After that, 32 bits for option field and 32 bits for data field. So guys, this is the TCP header. What do you mean by the headers? TCP work at which layer? Layer 3 or layer
Transport
2?
layer.
Transport. Food layer.
Ravi Shankar, will it work on layer 3 or layer 2?
Layer 2, sir.
Layer 2.
Hmm.
Okay. Lakshman, will it work on layer 3 or layer 4 or layer 2?
Layer 4.
Therefore,
Where are you, Ravi Shankar? You are saying it works on layer 2. It works, TCP and UDP works on layer 4 at transport layer.
sir, urgent pointer bits value.
So basically, header means extra information. Are you guys clear? Extra information which is added by transport layer in data. What is PDU at layer 4?
Segments.
And
Segment or data. Sorry, segment.
Segment. So for
segment.
layer 7, layer 6, layer 5, any information we are adding?
The data, right?
Yeah, it will be data only. No information, no extra information we are adding in data. Is it clear for everyone? For layer 7, it will be data. For layer 6, it will only be data. For layer 5, it will only be data. But when it will reach to layer 4, we add some extra information. Okay? And this will equal to called as layer 4. Lakshman, what is the
Segment.
PDU for layer 4?
Layer 4 is a segment.
I'm writing, but you are not seeing it, I think. So one
Uh,
segment will reach to layer 3. My screen is not visible for you guys?
yes, sir, visible,
Yeah,
visible.
visible.
Okay,
We can see.
okay. When this segment reach to layer 3, some extra information will be added here in form of IP header. What is layer 3 PDU, Abdul?
Layer two. Did you say?
Layer
Did you
3.
say layer three? I think on the network layer, I think it should be IP header
Yeah, IP
packet
header, but
packets. The packets, yeah.
yeah. On layer 2,
I think the packets that's gonna like convert into frames, I believe.
yeah. Okay. So these are the extra information. So minimum size of these information if data is using TCP protocol. So minimum size of TCP header will be 20 bytes and maximum size, what will be the maximum size? Anyone?
1500 bytes. 1500 bytes.
No, not 1500.
Is that for the whole the TCP header you're saying?
Yeah, I am saying only about the TCP header, not
Maybe
about the
it's
whole entire
uh,
segment.
60, 60.
Yeah, exactly. 60 bytes. Means minimum you can add 20 bytes information and maximum you can add 60 bytes information in original data. Is it clear for everyone?
So meaning
Why?
it's gonna be like in total, like how much is gonna be? It's 60 or 80? 20 plus?
No, no. 20 plus not 60.
Yeah,
Minimum 20 bytes,
right.
maximum 60 bytes.
Okay, maximum, right, okay. Yeah.
Okay?
20 watt minimum.
So minimum 20, maximum 60. It can be 40 bytes, it can be 50 bytes. Okay? In between the range of 20 to 60. Is it clear?
Right. Can you explain about this, like, in this table, the TCP header,
Yeah, yeah,
about
I am going to explain.
okay.
Don't worry about it. I am going to explain each and every field. So why we are adding these field? So that by seeing these field which is added in data, a receiver can understand this client is using TCP protocol. Okay, and it can make a connection according to the TCP protocol. Is it clear?
Sir, one more time, please.
Yes, sir.
Okay, this is a sender, this is a client, and this is the server. Client is sending some request, and with this data, server is saying a TCP header is added in this data. So it will understand, server will understand, client is using TCP protocol to send this data. He want a TCP connection. Are you getting my point?
Yes, sir.
Because these fields will be added with the data. Source port number, destination port number, sequence number, acknowledgement number, header length, reserve flags, window size, header checksum, urgent pointer. By seeing all these fields, a server will understand the client want a connection with the help of TCP. Okay, it will identify on the basis of the header. It will identify that client is using TCP protocol. Is it clear?
Yes, sir.
Surbhajit, Abdul, Ravi Shankar, Venkat,
Yes, sir.
Yes.
clear? So Ravi Shankar,
Yeah, clear.
Sir. Clear.
can you please explain why we use the TCP header?
Client is sending the data from server will be understand TCP protocols.
Okay. Abdul, is it clear for you also?
Yeah, yeah.
Okay. So source port number and destination port number. Port number. First we will discuss about the port number. Anyone has any idea?
It's the same, right? With the 65,536.
Yeah, it's same. So by seeing protocol number, sorry, port number, is used to identify which protocol is used at layer 7. Okay, so suppose that what is the port number of HTTPS
443.
443.
and what is the protocol of port number of HTTP
80.
80.
80. So if source port number will be 80, if source port number is 80, so once a receiver will receive this TCP header with 80 port number, it will understand at layer 7 which protocol has been used.
HTTP.
HTTP. The protocol, the port number is 443.
HTTPS.
HTTP. Yes. You know all these protocols are for CAN layer 7 only.
7. Yes.
Are you guys getting my point? What is the
Yeah,
rule
yeah.
of the port number? If port number is 179, which protocol use port number 179? Most important protocol. BGP. Okay. Why you use the port number? Is it clear for you, everyone?
Will this BGP work on the application layer as well?
Yeah, BGP work on application layer.
Okay.
Is it clear for you, Subhajit, Ravi Shankar,
Yes, sir.
Venkat, Lakshman, Abdul?
Yeah.
Clear? Why?
Yes.
Okay, but yeah, one doubt. I understand that port number and ICTP used application layer. Why? What is the reason to explain this in TCP header?
Why we are using port number at TCP layer? That is I am explaining.
Uh,
So that by seeing this port number, the receiver can understand which protocol has been used at layer 7.
okay, but the TCP works on layer 4.
So yeah, it works on the layer 4. So data will be processed starting from layer 7 to layer 6 to layer 5 to layer 4 to layer 3.
Oh yes.
Now is it clear?
Okay, it's clear.
And similarly, the destination port number. By seeing the source port number, it will understand which protocol used at the layer 7 by sender. And destination port number, by seeing the destination port number, it will understand that this data is stand for this protocol. Okay. The second field will be the sequence number. Anyone who has any idea for the sequence number?
Maybe it's gonna add the sequence numbers when dividing the data in like chunks, maybe.
Yeah. Go ahead. Anyone else?
Uh, each segments will be identified with the help of sequence number. So the data will be reached destination in the correct order. Even the
Yeah,
packet
so
is
that
lost.
we can reassemble, rearrange the data in correct order. Subhajit,
Yes, sir.
why we use the sequence number?
Don't know so much, but I think Lakshman said it.
Okay. Ravi Shankar, so
Sorry, I don't know that.
sequence number used to rearrange or reassemble the data so that we can get original data. So is it clear for everyone? Why do we use the sequence number?
Yes, sir.
Okay. The next field will be the acknowledgement number. Ravi Shankar, does TCP support the acknowledgement or not? UDP support acknowledgement. Venkat,
Yeah, only TCP will support acknowledgement, whereas UDP not support.
okay. So acknowledgement number used to send the acknowledgement.
During the the TCP and handshake.
Yeah,
Yes, yes.
not only for the three-way handshake and four-way handshake, for each and every packet. Let's suppose a three-way handshake connection has been established. I'm explaining it in a very detailed manner so that you guys will be clear about it. It's a very important topic for the freshers point of view. And now three-way handshake has been done and now we are sending the data. For each and every packet, receiver will send the acknowledgement. Suppose that this packet name is data1. Okay? This packet name is data2. For each and every packet, receiver will send the acknowledgement. Is it clear, Abdul?
Yeah, yeah.
Guys, is it clear for everyone? Why do we use the acknowledgement number?
Yes, sir.
Okay. So next will be the header length. It tells about the size of TCP header. It can be 20 to 60 bytes. So why do we use header length? Abdul, I told you minimum size of TCP header can be 20 bytes,
60 bytes.
maximum
60,
60
yeah.
bytes. Okay, by seeing the 4-bit of header length, okay, receiver will understand TCP has added 20 bytes or 50 bytes or 60 bytes header in the data. Okay? Is it clear for everyone? What is the use of header length?
Yeah.
Subhajit, Lakshman, Ravi Shankar, Venkat.
Yes, sir.
Yes, sir.
Clear? Why do we
It
use the
carries
header
the
length?
information that how
Yes, sir.
bytes of information.
Jaya, repeat your question. Anyone asking something?
Sir, one more is in port number. Port number is used to identify which protocol is used at layer 7. Only layer 7 or all layers?
Only layer 7. Because this data is processed by layer 4.
Okay.
Okay?
Sir, define the destination port number. Once more, sir.
Destination port number means
I think the destination port is gonna be the same, right? Whatever that you're trying to access in the browser. Say, for an example, if you're trying to access the email, or if you're trying to access the HTTP, HTTPS, or TFTP, whatever, that's gonna be the destination, I think, right? And source source port is gonna be your. It could be like a randomly selected from your computer, right?
suppose you want to access a file from the server and you are sending your data with HTTPS. Okay? What will be the HTTPS port number?
443, yeah.
And
That's
what will be the FTP port number?
the 21, 22, or 20?
Yes. So
Yeah.
it will add the 21 as in destination port. And what will be the source port? Because it's sending using the HTTPS. So the source port number will be 443 and destination port number will be 21. Let me give you an example. Suppose that here it is a DHCP server and it's a DHCP client. Let me explain it. DHCP client want a IP address from DHCP server. Okay, so DHCP client will add a port number of 68. What is the DHCP client port number?
67, 68.
67.
Yeah,
Six,
for 67, right? For sending data.
67 for client, 68 for sorry, server. Is it clear for everyone? So in the source port number field, it will add the 67. In the destination port number field, it will add the 68. Is it clear?
Yeah.
So once the
Yes,
DHCP server, once the DHCP server will receive this request by seeing the port number, it will understand this request is from a DHCP client. Okay. Is it clear for everyone? Lakshman,
yes, sir.
Yes, sir.
clear? So now the next will be the reserve. this field always be 0. It's by default field which set always be as 0. You need not to worry about it. And now we will discuss about the flags. Anybody knows how many flags in TCP? There are 4 flags in TCP. 8 flags, sorry. First one is sync flag. Second one is, it's a very important question. How many flags are in TCP? Acknowledgement flag. Third one is fin flag. Fourth one is reset flag. Fifth one is push flag. Sixth one is urgent flag. Seventh one is CWR, congestion window reduce flag. And last one is ECN, congestion notification flag. Once a synchronization message will send by the any sender, SYN flag will be on. Any acknowledgement sent by the sender or receiver, ACK flag will be on. When the four-way handshake will take place, then fin flag will be on. Okay, so in between of the data transfer, if is there any congestion on the route, then ECN flag or CWR flag will be on. If any urgent need of any data, then urgent flag will be on. Is it clear for everyone?
Yeah, could you please explain about CWR and ECN one more time?
CWR. And second one, ECN.
Yeah.
Okay. So Lakshman, are you clear about SYN flag, acknowledgement flag, fin flag? Venkat,
No, sir. One more time.
one more time. Okay. So first time when a TCP connection will start, then SYN message will send.
Yes.
So this time SYN flag will be on.
Okay.
Okay.
Yes.
Once it will send the acknowledgement flag, then ACK acknowledgement flag will be on. Is it clear for you, Abdul? Venkat?
Yeah.
Yeah.
Shubhaji,
Yes, sir.
is it clear? Ravi Shankar.
Yes, sir.
Sir. Yeah.
Once the four-way handshake will start, a FIN message will send from the client, then FIN flag will be on. Is it clear?
The terminating the session, right?
Yeah,
For the
terminating session. I want to terminate this session. Okay. Next one is the reset flag. If any you want to, that someone will send this data again, then reset field will be on. And next one is for the push flag. Venkat, what will be the push flag?
Uh, no idea.
No idea. So basically reset, push, these will be used by the quality of services. Suppose that all the data are in a queue. Data 1, data 2, data 3. But here I want to send data 4 before data 3. So what will I do? I will on the push flag.
so like setting up the priority, I think. Right?
Priority, exactly. Push flag is used to setting the priority. Urgent flag.
Can you give like an example in what situation this quality people they use this this push flag?
Let's. We will have to go in very deep, but you are asking, so
Yeah, very
let
just
me
like a
explain. Let me explain it. This is a router. This is a switch. Sorry. And PCs, a number of, suppose that 32 or 24, 26, 25 employees are connected with this switch. Okay. But in an office, in an enterprise network, uh, all the guys are working, but I want, if if router get any request from PC1, so always give a priority to this, because router also arrange the data in a queue and it will work first come first serve. But when the router get any request from PC1, immediately it will push it on the top. Like this PC1 is used by the CEO.
Yeah.
Okay. So now I am using the quality of services here.
So do they like make sorry make changes in the router? Where do we
We will have to we will have to, yes, you know, uh, transport layer will work on only on the router. So we will have to perform the set the quality of services only on the routers.
okay?
Okay,
Alright.
is it clear?
Yeah,
So where were urgent? Is it clear? Urgent field. The
right.
next
Yeah.
one is CWR. Suppose that it's a copper or fiber cable where n number of data is traveling. And bandwidth is, if suppose bandwidth is 1 GB and data is greater than 1 GB, like a road traffic. Okay, so congestion will occur or not? Venkat, you were asking about the CWR
Yeah. Uh, Bandwidth like 1 GB.
and data is more than 1 GB, 5 GB. So congestion will occur or not on this link?
Yeah. Yeah. It will occur.
It will occur.
Yeah.
Everyone has seen the road traffic in the evening time, especially. And if you are living in where you are living, Hyderabad or Bangalore?
Yeah. Bachelor.
Bangalore. The worst traffic situation nowadays in Bangalore.
Yeah.
Okay. So due to this, a congestion will occur. But have you ever seen in a heavy traffic uh, a motorbike can pass by here and there, but a car cannot pass.
Yeah.
So the same size, if we reduce the size of the packet, it will be easy
Yeah.
to travel in traffic. Is it clear for everyone? Abdul, are you getting my point?
Yeah, somewhat. But when we are sending this more than 1 GB data, right, to the router. Say for an example, if the router interface has like less than 1 GB, the, the whatever the cable is like
No, no,
using
I'm not talking about the router interface capacity. I'm talking about this cable capacity.
from the sender side, right?
It can be sender side or receiver side. Always
Mhm.
router will be connected with the cable.
Yeah, of course, but the request has to go through the router, right? When you're sending the information,
Yeah, maybe possible that this cable 1 GB data and 1
right?
GB data, both interface are 1 GB. And this cable has a maximum bandwidth of also if 1 GB. And at a time, both router are sending the data. So the total data will be 2 GB and the capacity of the cable will be 1 GB.
I mean,
So
how
congestion
the
will
router
occur.
if the size of the interface is like less than 1 GB,
No, if the size of the interface is 1 GB.
less than, for an example, I'm saying,
Less
and
than,
you're trying.
then congestion will not occur. then congestion
So
will not occur. You will increase the bandwidth, increase the bandwidth. If you are increasing the bandwidth, congestion will not occur.
okay.
Okay. So if we decrease the size of window, so it will be easy for the packet to travel in high congestion traffic. Okay. Is it clear for you,
Yeah,
Venkat?
clear.
Okay.
Yes, clear.
So the last field will be ECN. ECN is nothing. If suppose that here, I'm giving an example. If a data is sending from into server and server is getting that ECN bit is on with the data. Okay. If ECN bit will be on, it will understand that there is a congestion on the link. It is nothing. It just shows to a server or client that there is a congestion
Yeah,
on
yeah,
the
okay.
link. So all the field we will have to discuss about the header checksum, urgent pointer, option field and data field. So guys, we are taking 10 minutes break. After that we will discuss these fields. Okay?
Yeah, yeah, okay.
Lakshman, all the fields are clear for you?
Except that ECN last flag.
ECN flag.
Yes, sir. I confuse with both flags, CWR flag and ECN flag. CWR flag helps to reduce the congestion. It notifies to reduce the when that is when like when there is congestion, it reduces the bits. CWR flag. Am I correct?
Yeah. And ECN will notify you there is a congestion on link.
Oh, ECN will detect and CWR will perform the
Yeah,
action.
exactly.
Oh, okay, sir.
And all others? Source port number, destination, sequence number, acknowledgement, header length, reserve.
I understand port number, but source port number, destination port number, I not understand.
So it will take I think, more than half an hour to dig this point.
Okay, sir. I will rewind the video.
Yeah, because I don't
Still
think
not.
at CCNA level nobody is going to dig all the flags.
Yes, sir. Understood, sir.
But I am explaining each and every point here. It took almost one hour, but we could not complete it.
Yes, sir. Can you give me the simple definition of source port number and destination port number to perform in interview?
So simply you can say for the source port number, with the help of source port number, we will identify the protocol used at layer 7.
For destination port number?
For destination port number, we can say with the help of the destination port number, by saying the destination port number, a receiver can understand this request is for this particular protocol.
Yes, sir.
Okay.
Yes, sir. Understood.
So the next will be the window size. Anyone who is remaining? Okay. So window size. Window size is nothing. window size tells that what is the capacity of a router, means how much data the router can process at a time. Okay, suppose that suppose Venkat is sending some data to Lakshman, and Venkat is saying, "Hello Lakshman, don't send me the data greater than value of 2 GB because I am not able to process a data packet which is more than 2 GB in size." By seeing this window size, a router or a server can understand the capacity of the sender is only this size. Is it clear?
Or maybe the router is going to like negotiate.
Yeah, before sending the data, it will negotiate. But a router will identify that my capability is only, suppose that 100 bits or 200 bits or 500 bits or 1024 bits or 512 megabits. So this is my sites, this is my capacity, and you cannot send beyond than that. Is it clear? Venkat, window size is clear for you?
Sir, in simple, window size helps to identify the capacity of the router. Right?
Yeah. Window capacity of the router. Subhaji,
It's clear.
do you have any doubt?
Yes, sir. The capacity of interface or something.
Capacity of a particular capacity of the window. We discussed at the data link layer the windowing process. Okay. So
Okay.
before sending the data, router will divide it into the chunks. Okay. Here you can see its entire data, but here router is sending in it into the chunks. Suppose that each chunk's window size is 100 bytes. Okay. So beyond that 100 bytes, if server will send the data, then router will not, the client will not able to receive. So by seeing this window size field, a negotiation will be done that maximum size of data we can set for each window will be 100 bytes. Is it clear?
Okay, sir.
Actually, here window represents what, sir?
Window, can you please repeat your question?
Uh, Here window specifically represents whether it is a specific packet or like.
Not a specific packet, it's a general packet, not a specific packet.
Okay.
Okay. So the next one is header checksum. Anyone who has any idea about header checksum?
I think it's when we move to the data link layer, right? That's when it's gonna do the checksum. I think is it layer two?
Yeah, we discuss about the checksum.
Yeah, with
Checksum,
the
the
matrices.
similar work here also. With the header checksum, layer 4 will do a error detection and correction. Is there any error in data or not? Error detection. Okay. Urgent pointer. For the urgent pointer, anybody who has any idea? It's clear from its name, urgent pointer. How many working guys are here?
I think it indicates about the, like how the incoming data is as urgent.
Yeah. Suppose Lakshman, Venkat, and Abdul, these guys are working in a same organization, and Lakshman is sent at the end of the day. Lakshman have to update Abdul, okay, and Abdul at 2 o'clock afternoon, Abdul is saying, Lakshman, urgently send this file to me. This urgent pointer has same work to identify. Please send this data urgently, because when the receiver will rearrange the data, it may be possible that suppose I will have to open a new tab. Suppose data 1 packet, data 2, data 3, data 4, data 5, and receiver has received data 1, data 2, data 4, data 5. Receiver doesn't have data 3. Okay. So at the time when the receiver did not get the data 3, it will point out to the sender, please send data 3 urgently, because I am not able to reassemble or rearrange the data because I don't have the data 3 packet. This is the role of urgent pointer. Is it clear? Guys, please respond. Give me a response.
Yeah, it's clear.
Yeah, I mean, when you're explaining, we are getting that point. But when if you could like try and connect with the production environment, how it works in the production environment, that way, like, and we can be more clear on that.
Sir, whenever the specific data is missed,
Uh,
by using different pointer, the data will be can be easily read, right?
yeah. So production environment, it is very tough. Abdul, let me give you an
This,
example.
you can just explain in
Yeah.
one.
No one explained, I think, TCP header
Mm.
in so deep manner. But I am explaining it because You guys are asking to be. It's a very good habit. No issue. I think it will take 1 hour, more than 1 hour.
No, just with the, we
Okay.
could just explain in like
No
few.
issue. No issue. No issue. Suppose you have to send 5 files to with file number 1, file 2, file 3, file 4, file 5 to Lakshman. And Lakshman can only obtain a result after doing a proper rearrangement of these five. Okay? And Lakshman has received file number 1, file number 2, file number 3, file number 4. Sorry, file number 4 and file number 5. But Lakshman don't have the file number 3. So he is not able to get a meaningful data. Okay? Lakshman, by seeing this field 4, 5, Lakshman can understand that file 3 is missing. Are you getting my point? Sometimes you have observed on a WhatsApp message, you send a message and after that you send a message. But sometimes the latest one will send first and the first one send in the last due to some network issues.
Right, yeah.
Yeah, have you experienced it?
Yeah.
Okay.
It happened.
Yeah. So the added this time when Lakshman will not receive, Lakshman will see that this is file 4, but he hasn't received any file 3. Urgently, he will send a message to you, send me this file 3. Okay,
Right.
right?
Yeah, got it.
Next one is option. What do you mean by the option?
That for the like extra information, is it? Optional
Extra
means.
information. It is optional. Either you, if you are sending it, it will be better. If you are not sending it, it doesn't matter. Okay? It's totally optional. Like you are sending the timestamp. Each and every data has a timestamp. Suppose that at 5 o'clock, at 5, I send this packet. At 5:02, I send this packet. At 5:04, I send this packet. So this is optional. If you send this, it will be helpful. But if you not attach the timestamp, then it will not create any effect on your data. Will it create any effect to rearranging and reassembling the data?
No, sir, it will not make any effect. I think so
That
because
is why
there
it's
another.
totally optional.
Sir, instead it can use sequence number. Am I correct?
Sequence number. Yeah, you always already have the sequence number. Then is there any need of timestamp?
Yes, sir. Yes, sir. That's what I'm trying to say.
Yeah, you already have a sequence number, so there is no requirement of the timestamp. You already have the header length field, and if I am sending the MSS maximum segment size field, You already has the header length. So there is no requirement. Okay? Is it clear? So this field is totally optional field. And the last one will be your original data. So now TCP header is clear for everyone. We have completed TCP header from the port number to data. Anyone has?
Sir,
Any
one
doubt?
is like checksum is used for error detection. Am I correct?
Yes, checksum is used for the error detection. Header checksum is for used for the error detection. Venkat, is it clear? Every field?
Yeah, it's clear.
Abdul?
Yeah, it's clear. Just one question, while windowing, right? During the windowing as a sender, if I'm like unsure about like what is the capacity of the interface, how is it going to like negotiate, with the data?
So by seeing the window size, window size,
Yeah,
windowing size, field router will understand
yeah,
that
because
this is the
as
size of the window.
knowing, right, what is the capacity of the router
Yeah,
interface?
yeah.
I'm not trying to like send like a 4 GB or 5 GB data.
So
So how?
if the capacity is 1 GB is coming from the client side, then you can understand I will have to send only the 1 GB data. We will have to divide the 5 GB data into chunks. 1 GB, 1 GB, 1 GB. We will have to divide 5 GB data into the parts of five parts.
Do I, as a sender, do I have to do it or manually, or I mean, if the router is going to negotiate?
The router will negotiate.
Yeah, that's what.
Manually,
Okay.
you need not to do anything. Router will negotiate it with the server.
Okay, it's doing on the layer two
And
network. Yeah.
nothing will be done by here by the end user.
Okay.
Okay.
Right.
Now we are going to discuss about the IPv4 header. I think we will not able to complete it by today. I want to start routing in the next week. But this is a very important topic. Anybody? Who can help me? Priority and type of service. Subhajit, you are from computer science background.
No, sir.
Total length.
No, it's like a 32 byte, right? IPv4.
Yes. 0 to 31. Total 32.
Yeah.
Anyone who has any idea about TTL?
Yes, sir.
It's time to
So
leave.
Time to leave, yes.
the packet reaches router, the TTL value will be decreased. So whenever it comes to 0, uh, unable to reach message will be sent if the destination has not reached.
Okay. We will discuss. Don't worry about that. Here also header checksum.
For Windows, TTL value is 128, and for router, it is 255.
Yes, exactly. So what is the minimum size of IPv4 header? Anyone? Nobody knows?
Maybe as we discussed before, I think minimum we said like a 20, right? 20 bytes.
Yes, exactly. Maximum?
60. Yeah.
Okay. So the version field will give the information about the version of IP address. How many versions of IP addresses?
2. IPv4, IPv6.
So by seeing the version field, will it be clear? Either it is version 4 or version 6? Okay.
Yeah.
Okay. The next will be the header length. IP addresses work on which layer, Venkat? Either on layer 4, either on layer 3 or layer 2.
Uh, Network layer, layer 3.
Ravi Shankar?
Network layer, sir.
100%? Are you sure?
Sir.
Okay. So header length will tell you length of IP header. What will be the minimum length?
20 for the header, right?
Yeah, yeah.
20.
20.
4 bit, sorry, 4, I
When
think, right?
minimum will be 20 byte.
Yeah.
Maximum
Maximum
60.
okay. The next will be the priority and type of services. Abdul, I explained this point in TCP header for you. These bits are described
You said the quality of service, was it?
exactly.
Yeah.
Traffic class. So anybody can tell me quality of services uses at the enterprise level or ISP level. Quality of services only used at the enterprise level router, not on the ISP level router. Okay?
Yeah.
For traffic, is it clear for everyone why do we use priority and type of services field?
One more time, not understand.
So by seeing this field, router will understand for which top traffic I have to give the priority and for which traffic I don't have to do any kind of priority. Okay?
Yes, sir.
Total length. Next one will be. Anyone? It tells about what is the PDU at layer 3. Abdul,
Packet.
Yeah, packets.
we receive segment from layer 4 to layer 3 and in segment field we will add the IP header. After adding the IP header, the new PDU will be packet. So it,
Which includes the destination and the source and the destination, right? With the IP address and all.
yeah.
Yeah.
So it tells about the total length of the packet, total length or total size. Total size, you can say also the total size. of the packet. Okay. Is it clear? Total length
Yeah.
means segment plus IP header. Lakshman, is it clear? Venkat.
Yes, sir.
Yeah, clear.
Okay. The next field will be identification. Okay. So we have a field source IP address. We will discuss about the identification later. The source IP address will have the information about the source of this packet. Suppose that a PC which IP address is 10.0.0.1. It's create a packet which comes to switch, and from switch to router R1, router 1 to server. So the source pack, if a packet is going from here to here, the source IP address will be 10.0.0.1. So it's indicate about source IP address of a packet. Remember this point. In entire TTL, source IP address will not never be changed. Any router will not perform any change in the source IP address. Okay? Our destination IP address. Are you getting my point, everyone? Give me
Yes,
a
sir.
response.
Sir, but MAC address can be changed. It's no.
How can MAC address will be changed? Tell
No,
me.
no. I saw the packet flow video yesterday, so I am saying this.
How can be a MAC address changed?
In
In
router,
prox,
when there is
yeah, tell me.
in router like oh, how can I say this? Sorry, sir. Gateway. When the packet goes to gateway, it changes the MAC address to another, like another default gateway MAC address. Like that, whenever the packet goes, it will change.
No.
Okay.
We will discuss this point when once we will discuss the proxy or you are confused.
Okay. Okay, sir.
I got the point where you are confused. Destination IP address. Suppose this packet is for 11.0.0.2. The source IP address will be 10.0.0.1 and the destination IP address will be 11.0.0.2. Is it clear for everyone? Guys, please give me a response.
Yeah,
Yes, sir,
yeah.
it's clear.
Okay. The next field is TTL. Time to live. Anyone who want to explain TTL?
I think whatever the default value of the total time to live in the router, it's gonna discard the packet after like a certain time. Whatever Subhijit was saying about like router TTL is like 253 or 258, whatever.
Okay, let me explain it.
I think
Yeah,
255.
whenever any packet cross the L3 device, the TTL value will be decreased by 1.
Yes, exactly. Let's suppose router R1, R2, R3, R4, R5. So TTL value for the routers will be 255. What does it mean exactly? For maximum 255 routers can process this packet. Means maximum 255 routers, we can send this packet to maximum 255 routers. Suppose that here is a packet data 1, it has a TTL value of 255. Once it passes to R1, the TTL value will to 254. Once it passes to R2, the TTL value will decrease by 1, 253. When it passes to R3 to R4, here 252. Suppose again R4 is sending this to R3. Again the value will decrease by 1. Okay. Now if R3 is sending this packet to R5, so the TTL value will be 250. And R5 is sending this to R4. And R4 again sending this to R5. Now what will be the TTL value?
248.
Yeah, 248. So maximum 255 operations can be done by routers on a particular packet. Why do we use this TTL value? So that we can avoid the loop. We use TTL value to avoid
So
the
that layer 3 loop.
layer 3 loop. Is it clear for everyone? Suppose I am sending a data for router R7, but none of these routers have the capacity to send this data to R7. And a packet is, they are transforming the packet from one to each other only in a loop, as I show in the diagram. R3 is sending this packet to R4. After that, R4 is sending this packet again to R3. And R3 is sending this packet to R5. R5 again sending this packet to R4. R4 again sending this packet to R5, and this cycle goes on. So now here a packet is stuck in a loop. Getting my point, Venkat?
Yeah.
Yeah. To avoid this loop, we use TTL value. Is it clear, Abdul?
Yeah.
Lakshman, Ravi Shankar,
Yes, sir. Understood.
Clear, sir.
Subhajit?
Yes, sir. Understand.
Okay. The next one is header checksum. Header checksum used for
The same, right? To detect the
Error
yeah,
detection.
yeah. Okay. Protocol. Identification and flags are the remaining fields, because I am not touching today identification and flag. We will not able to cover it. Okay. And if I will cover only identification and not will cover the flag, then tomorrow you will not able to understand it.
Okay,
So,
sir.
okay. So we will cover the identification and flag offset tomorrow. And if you have any doubt and protocol also, you can ask me. Whatever the we discussed today. Abdul, it is clear for you? Every point?
yeah.
Ravi Shankar,
Sir,
Venkat,
Clear, sir.
someone is
Again, about
asking.
some of this, the
sir,
topic,
one request, please. Destination port number definition. I missed that point. With the help of destination port number, the destination device will identify the port. Like,
This client is requesting for this service. I explained in the at the DSCP by taking the example of the DSCP. I explained you.
okay, okay.
Okay?
Yes, sir.
Yeah. Anyone? But you know, DSCP never use TCP. DSCP always use only UDP. This was an example only. Okay?
Okay.
Lakshman?
Yes, sir.
Yeah. Venkat, you were asking something.
No.
No? So guys, that's is sufficient for today, and we will meet tomorrow, and we will discuss about the identification field, flag offset, and we will discuss about the UDP headers also tomorrow in Ethernet header. Okay?
Yes, sir.
Yeah. Okay.
Okay, sir.
Okay.
So make sure that you cover all these points of this IP header and TCP header, because it's a very important question for the TAC interview. Especially if Lakshman, if you will apply in Chennai for the CSS core, definitely in the interview they will ask you. Definitely.
Yes, sir.
More than 10 of my colleagues, they applied for the CSS corp interview, and they told me that they are asking about the headers.
Yes, sir. Very detailedly.
Yeah, they will ask you in the detailed manner.
Yes, sir.
That is why I'm explaining it. Okay? So thank you guys for today's session. We will see you
Yeah.
tomorrow.
Thank
Thank
you.
you, sir.
Thank you, man.
Thank you, sir.